All right, so this is number 44, approximating the function value. So we want to use calculus actually to approximate that value. Instead of typing it in your calculator to figure out what this is, we're going to try to do this by using calculus. So, I mean, if you type that in your calculator, you could take the cube root of 26 and get a value. But we could do it without it, right? So first of all, what you got to decide is, okay, what is my function that I could take the differential, so, right? So y equals, in this case, this is a cube root function. So that's the function you got to use. So does everybody understand where I got this from, right? This is a cube root, so the function is y equals x to the 1/3, or you could write it as cube root of x. So that's my function. So now you got to decide, okay, what can you take the cube root of and get a whole number? So in this case, I would say 27, right? Cube root of 27 is 3. So I would make x be 27, right? And this number, this actual number, is off by 1, right? So my delta x, or dx, will be -1, right? Isn't that right? Okay. So now we're going to use our differential to estimate this. So here it is, right? We're going to take this, we're going to find dy, right? dy is the derivative times the dx. So derivative of this is 1/3 x to the, when you subtract 1, I get -2/3. -2/3, right? And then times dx, which then gives you 1/3 with a x to the 2/3 in the denominator times dx. That's what I get, okay? So now dy is 1 divided by 3 times 27 to the 2/3 times -1. So we know the cube root of this is 3, right? Cube root of 27 is 3. Squared that will be 9. So this part right here becomes 1/3 times 9 times -1, which then is -1/27. Okay? Make sense? So the estimate of this value, so the cube root of 26 is, well, we know the square root of 27, which is 3, right? We'll take that and we subtract 1/27, which then gives me 2 and 26/27. So this is approximately that. And that's how you approximate the value of the cube root of 26. Was that hard?
I just, when I first heard the question, like, wait, what are they asking me to do?
Yeah. Using the differential, approximate the value of this. So that's how you do it. Because we know the square root, the cube root of 27, right? Cube root of 27 is this, and this is the difference between these two, right? So I subtract that, and that's what I get. Which, if I type in my calculator, right, I could do a cube root of 26. 1 divided by 3 is, so this, if using a calculator, it turned out to be 2.96249. And then this right here, 26 divided by 27. And then if I take that, this right here is 2.9629629663. So I'm off by just a, right? Just a little bit right here. So that's my approximation. Okay? This is this. Actually, that's that. So I approximate the value of the cube root of 26 using differential, right? That's not bad, is it? Okay? The tricky part is probably figuring out what your y is. What is your y, right? So it's whatever the function is being done to the number. Okay?